In this video, let us discuss about how to derive the moment generating function, mean and variance of the geometric distribution. The probability mass function of the geometric distribution is given by probability of capital X equal to small x is equal to P Q x minus 1, and x varies from 1 to so on to infinity. Here x starts from 1. In case of binomial and cosine, x starts from 0. Here x starts from 1. Now, how to derive the moment generating function, MGF? The formula to calculate the moment generating function is given by mx of t is equal to summation x varies from 1. So x varies from 1 to infinity e power tx into probability of capital X equal to small x is equal to summation x varies from 1 to infinity e power tx can be written as e power t the whole power x. Probability mass function is given the problem p q x minus 1. Here p is a constant, we can take p outside, only x varies here. So I am taking p outside from the expression x varies from 1 to infinity e power t whole power x. Q power x minus 1 can be written as q power x and q power minus 1. Now I am taking q power minus 1 outside because q power minus is a constant. So already we have p here divided by q. Because q power minus 1 can be written as 1 by q, and summation x varies from 1 to infinity, and e power t and q has got the same power, so we can multiply e power t and q. So e power t and q we can multiply x. Now we start expanding x. So p divided by q, substitute x is equal to 1. I am getting e power t q. If you apply 2, e power t q the whole square. If I apply 3, e power t q whole power 3, this will continue till infinity. Throughout the expression, we can notice that e power t q is a common term, so we can take e power t q outside from the expression. Therefore, is equal to p divided by q. I am taking e power t q outside from the expression. So 1 plus e power t q plus e power t q the whole square and so on to infinity. You can cancel q and q. So we are left with p e power t 1 plus e power t q e power t q the whole square so on to infinity. So this expression is a well-known expression, so this expression can be written as 1 plus x square so on to infinity. So this can be written as the formula 1 minus x whole power minus 1. Similarly, this can be written as p e power t 1 minus x. Here x, this is x. So this is our x here. So this is x over here. So instead of x, we can replace e power t q whole power minus 1. So our answer is p e power t divided by 1 minus e power t q. This can be further simplified so that our mean will be very simple. So we can take e power t or e power t outside from the expression. So we are left with only p. In the denominator, you can take e power t outside. So he will be having 1 by e power t. Here q. So cancelling e power t, we will be having p divided by 1 by e power t can be written as e power minus t minus q. So this is a moment generating function of the geometric distribution, that is mx of t equal to p divided by e power minus t minus q. So this is a very important step. If you're taking e power t outside, there is no e power t here, so we can write as 1 by e power t. So if you multiply e power t inside, both get cancelled, so answer becomes 1, and this will get inside. Okay. Now let us discuss how to find the mean and variance. The formula to calculate mean: e of x equal to d by dt mx of t at t equal to 0. Mx of nothing but the moment generating function is equal to d by dt, the expression for mx of t which you have calculated now, p divided by e power minus t minus q at t equal to 0. Now we are going to differentiate this one with respect to t using u by v formula. After derivative we can apply t equal to 0. So this is the form p by q formula. So first I am going to square the denominator, e power minus tq whole square. Now we'll keep denominator as it is, e power minus t minus q. If we differentiate p, the answer is 0 with respect to t, the answer becomes 0. Now we'll keep p as it is, differentiating e power minus t minus q with respect to t. If we differentiate e power minus t, what is the answer? The answer is minus e power minus t. If we differentiate q, the answer is 0. Okay. Now before applying t equal to 0, let us simplify so that we can use this answer for the second term, for the second order moment. So this becomes 0. So minus and minus becomes plus. So the answer is p e power minus t minus q the whole square at t equal to 0. So this expression we can use later for calculating the variance. So I'll give equation number 1. Now apply t equal to 0, e power 0 becomes 1, e power 0 becomes 1. So p divided by 1 minus q the whole square. As we know, for both binomial and geometric, p plus q is equal to 1. So p can be written as 1 minus q. So this becomes p. So p divided by p square. 1 minus q can be written as p. So here we have square here, so p. So both can cancel, the answer is 1 by p. So 1 by p is the answer of mean. In similar fashion, we can able to calculate this second order moment, that is e of x square, which is very useful to calculate the variance. So now we'll be going with e of x square. The formula, the same formula over here, d square divided by dt square mx of t at t equal to 0, which means we have differentiated 2 times. As you notice, equation number 1 stays, we have differentiated mx of t once. Okay, so we can use equation number 1 over here. So d by dt, which means I differentiated once earlier. So mx of t nothing but the answer p e power minus t divided by e power minus t minus q the whole square at t equal to 0. Okay. Now before differentiation we can take the constant outside, we can take p outside. Now this is the form u by v model. So you know, differentiating e power minus t minus q, first you must differentiate the power, which means you must take the power to the base. So 2 times of e power minus t minus q. Now differentiating the base. As you know, differentiating e power minus t, the answer is minus e power minus t. Differentiating q, the answer is 0. So this is the answer of differentiating this term. Okay, we can use later. So this is of the form u by v model. So first we are going to square the denominator. So e power minus t minus q. If we square, the answer becomes 4. Okay, already we have square here, so the answer becomes 4. Now we'll keep e power minus t minus q as such. Differentiating e power minus t, the answer is minus e power minus t minus. Now we'll keep e power minus t as it is. We already taken p outside. Okay, so we'll keep e power minus t as it is. Differentiating e power minus t minus t whole square, the answer is over here. Okay, so 2 times of e power minus t minus q minus e power minus t at t equal to 0. Here we can apply t equal to 0 directly. No need to simplify like mean. Okay, we can apply directly. So what happens when you apply t equal to 0? E power 0 becomes 1. Okay, the answer becomes 1 minus q whole square. E power 0 becomes 1, so the answer is negative 1. Okay, here e power 0 becomes 1, the answer is 2. E power 0 becomes 1, the answer is 1 minus q. E power 0 becomes 1, here we are negative. Okay, so minus into minus becomes plus over here. Okay, so whole divided by, similarly apply here 0, e power 0 becomes 1, So 1 minus q the whole power 4. So p into, what is the value for 1 minus q? The answer is p, correct? So the answer is minus p square. Since we are negative here, so minus p square. 2 into, what is the value for 1 minus q? The answer is p. Okay, this is 2p. Okay. Divided by 1 minus q. What is the value for 1 minus q? The answer is p. The answer becomes p power 4. So p, from this expression we have p as common, right? So we can take p outside. So we are left with 1 minus p, simply p, and we have only 2, correct? We have only 2 whole divided by p power 4. Here we are left with only p. Okay, so this can be further simplified as, we can cancel p and p. So we can cancel p and p. So this terms becomes, we cancel, the answer becomes minus p plus 2 divided by p square. Okay, so this can be further written as, 2 can be written as 1 plus 1, right? So 1 plus 1 minus p divided by p square. Okay, what is 1 minus p? It is q. So 1 plus q divided by p square. So this is the answer for the variance, sorry, second order moment. Okay, now we'll try with the variance. Formula to calculate the variance. Variance of x is equal to e of x square minus e of x the whole square. What is the answer for e of x square? Just now we derived the answer, 1 plus q divided by p square. 1 plus q divided by p square. The answer for e of x, that is 1 by p. So 1 by p the whole square, since we have square over here. Okay, so common denominator, we can take this p square. So 1 plus q minus 1. 1 square is 1, right? So 1 and minus negative 1 get cancelled. The answer is q divided by p square. Okay, so this is the variance of the geometric distribution.